You know, when you look up at the sky, see those soft, puffy clouds drifting by, and think, man, they look as light as cotton candy. Well, in this explainer, we're going to dig into that idea, and I promise you, we're going to uncover a reality that is, well, shockingly heavy. Okay, let's just dive right in. Picture one of those classic fair weather cumulus clouds, the kind you see on a perfect summer day. Just take a guess. Right now, what do you think it weighs? A few pounds? Maybe a ton? The answer is going to completely change the way you look at the sky. Yup, you're seeing that right. 500,000 kilograms. For those of us who think in pounds, that's over 1,000,000 pounds. That little puffball that looks like it weighs nothing, it has some serious mass. To try and wrap your head around that number, a single cloud weighs about as much as a fully loaded Airbus A380. That's the world's largest passenger airplane. Just imagine an entire jumbo jet, packed with people and fuel, just floating around up there. That's the kind of weight we're talking about. It's wild. So, the obvious question is, how is that even possible? How does something that looks so weightless get so incredibly heavy? Well, to figure that out, we need to look at the recipe for making a cloud. It all starts with the real basics. You've got warm, wet air rising up from the ground. As it gets higher up, it starts to cool down, and all that invisible water vapor condenses into, and this is key, trillions of tiny liquid water droplets. And that's it. That's fundamentally how a cloud is born. Now here's the thing. Each one of those droplets is smaller than the width of a human hair. You'd never ever feel its weight on its own. The secret isn't in how heavy one droplet is, but in their sheer, staggering number. A normal cumulus cloud can be a kilometer wide and a kilometer tall, just a massive volume of this stuff. And this is exactly why our intuition gets it so wrong. Our brain sees this big, spread out, diffuse thing, and it just registers it as light, kind of like foam or cotton. It's the same reason you don't really feel the immense weight of a lake just by looking at its surface, right? The mass is distributed over a huge area. Which, of course, brings us to the great paradox of all this. If a cloud is as heavy as a jumbo jet, why is it just hanging out up there? Why doesn't it all just come crashing down on our heads? Let's tackle that question head on. I mean, an airplane needs these incredibly powerful engines just to fight gravity. But a cloud, which weighs just as much, seems to do it without any effort at all. So what's its secret? The answer is this really beautiful, constant battle between two forces pushing in opposite directions. You've got gravity, which is relentlessly pulling every single one of those trillions of water droplets down. But fighting against it is the powerful push of rising warm air, what scientists call updrafts. These two forces are locked in this constant, delicate dance. Okay, so let's break that down. Because those water droplets are so tiny, they have a lot of air resistance, so they fall incredibly slowly. At the same time, that column of warm air that made the cloud is still rising, and it's rising way faster than the droplets are falling. So the updraft is basically holding all those droplets up in the air. The whole system, the cloud, the warm, moist air, all of it, is actually less dense than the cooler, drier air around it. It floats for the same reason a hot air balloon does. So the really crucial moment is what happens when that balance finally breaks. Up inside the cloud, all those tiny droplets are constantly bumping into each other and merging, kind of clumping together. As they do, they get bigger and heavier, and eventually they get so heavy that gravity's pull on them is finally stronger than the updraft's push. And at that exact tipping point, boom, you get rain. That's the moment the cloud literally can't hold on to its own weight anymore. But of course, that 500,000 kilogram number we talked about, that's just for one type of cloud. The sky is full of all kinds of different cloud characters, and their weights can vary dramatically. And the differences are just stark. You have those thin, wispy cirrus clouds made of ice crystals. They're super light. Then you've got our good old cumulus cloud, clocking in at around 500,000 kilos. But then you have the cumulonimbus, the thundercloud. These things are the true giants of the sky. A big storm cloud can hold tens of millions of kilograms of water and ice, okay? So we're not talking about one airplane anymore. We're talking about a whole fleet of them. These things are colossal atmospheric engines, just churning with unbelievable mass and energy. And the science isn't just about stuff way up in the sky. Fog is basically just a cloud that's touching the ground. A single cubic kilometer of dense fog can hold the same amount of water as that fluffy cumulus cloud we started with, over 500,000 kilograms. and we walk right through it, completely unaware of the incredible weight that's just suspended in the air all around us. So, okay, this is all fascinating trivia, right? But does it actually matter? Oh, absolutely. This isn't just about how heavy a cloud is. It has a huge impact on our entire planet. Understanding how much mass is in a cloud is absolutely critical for science. Meteorologists use it to predict how much rain or snow is going to fall from a storm. And on a much bigger scale, the weight and the type of clouds out there are a huge factor in our planet's climate. In fact, figuring out how clouds will behave in a warming world is one of the biggest questions in all of climate science today. And this really shows you how complex it is. Those heavier, low-level clouds, well, they're dense with water, and they act like a giant mirror, reflecting sunlight back out into space and cooling the Earth. But the thin, high-altitude clouds do the exact opposite. They let the sunlight in, but then trap heat that's radiating up from the surface, creating a warming effect. It's this incredibly delicate planetary balancing act. So I guess the big takeaway here is this. The next time you look up, don't just see a fluffy white object. Try to see what's really there. A massive, dynamic, powerful atmospheric system, constantly in motion, balancing immense weight against the forces of nature. This quote really just captures it perfectly, doesn't it? Clouds are this beautiful paradox, these enormous, heavy structures being held up by the collective power of trillions of microscopic particles. It's a testament to the elegant physics that run our entire atmosphere. It really makes you wonder, doesn't it? What other everyday things that we completely take for granted are hiding these incredible forces and this immense scale, just waiting there for us to look a little bit closer?